Good morning, everyone. This is Mr. V. Rajshekar Reddy. So, working as an assistant professor in the chemistry department, freshman engineering, St. Martin's Engineering College. Today, my topic is, and we are going to discuss about corrosion and its control methods. So, here, elaborately, when you see this corrosion and its control methods, so first we will see the definition, next causes, effects, and control methods. So, coming to the major what is the definition of the corrosion. So corrosion generally is defined as a damage or deterioration of a material, okay, usually a metal due to the chemical interaction in the corrosive environment. So when there is a chemical interaction of a material, usually a metal, so there is a chemical deterioration, so where the metal is converted to oxide. So in this way, we can know that what are the major causes of the corrosion. So major causes of the corrosion, you can see nature of the metal or alloy. So next, presence of foreign matter at the surface. Next, homogeneity of the metallic structure. So how can we broadly classify this type of the causes? And next, what are the major effects? Okay. So first we can see the definition. So what is the corrosion? So corrosion is defined as the damage or deterioration of a material, usually a metal, due to a chemical interaction or reaction with the corrosive environment. So coming to the major causes. So coming to the nature of the metal or alloy. So there is a native state and a combined state. So what is the native state and what is the combined state? When you are coming across this, how this metal is, we are preparing the metal means, so generally by the metallurgical operations of the ore. So ore is a completely thermodynamically stable compound. So from that we are preparing the metal. So metal from the thermodynamically stable compound, we are preparing the metal. So metal is an active state. Okay. And next are alloy. So alloy alloy nothing but the combination of the two metals. So when this thermodynamically stable compound it is converted to metal, it is in highly reactive state. Okay. So this highly reactive state compound definitely undergoes corrosion in the corrosive environment, and it is decomposed and finally converted to corrosive metal, and also it is releasing the oxygen. Next, presence of foreign matter at the surface. So presence of foreign matter means, you can see, so whatever the impurities and whatever the other substances, so it is leading to the formation of a corrosive environment. So that is a most vigorous process where it forms a tiny electrochemical cell. So that elaborately will discuss in this point. Next, homogeneity of the metallic structure. So some metallic compounds are completely prepared with only one type of metal. So that type of metal are prone to easy corrosion in the corrosive environment. So how can we control that? We can see next. So weather conditions. What are the weather conditions? You can see. So metals are on exposure to environment elements like water, wind, and air. So moisture. Okay. So they oxidize the metal surface, and it is leading to the formation of a metal oxide film. So in this way, the corrosive environment. So it is a major part. So where it leads to all the highly active metals are converted to corrosive metals. So you can see the examples like iron. Iron is converted to iron oxide. Next to aluminum is converted to aluminum trioxide, and next to copper is converted to copper carbonates. So in that way, so weather conditions are the major chances for the all these highly active metals are converted to oxides. So that is a unstable. Okay. Next, harmful gases and chemicals. So what are the harmful gases when this corrosive environment you're coming across is harmful gases means, so like sulfur dioxide, next chlorine, next oxides. So all this type of ammonia, chlorine, sulfur oxide, and hydrogen oxides, acids and bases are having the chances to take up the an electrochemical cell in the presence of a anode and cathode, and finally converting that pure metal to a metal oxide. So in that way, you can see one example. So oxidation of copper wires, where the completely copper is converted to carbonates. So this is the example you can see in the presence of harmful gases and chemicals. Next, biological substances. So all type of biological substances like dirt and bacteria are the chances for this corrosion of the metals. So you can see the inland pipes where they are prone to the maximum harmful bacteria and also moisture. So there is a major chances for this damage of this inland pipes, and also the underground wire lines. So this is the general causes of this different conditions. Under different conditions we can see the how these metals are corroded. Next, unstable nature. So what is the unstable nature means? So generally all these metals are in highly reactive mode, so they have higher energy state, so they tend to convert, they have the more prone to go to the lower energy state and become the stable. So in this process what happens, all these metals when they are exposed to the different types of moisture like oxygen or moisture, any type of corrosive liquids, okay, so this metal is converted to metal oxide. You can take example, iron is converted to iron oxide. Next, copper is converted to copper oxide. Next, aluminum converted to aluminum trioxide. So next, it is completely decomposed. Okay, so metal oxide completely decomposed, and we can get the final product, corrosive metal plus oxygen. So this is a general process we can see in this corrosive process. Next, what are the factors that are more increasing, and there are more chances for the rate of corrosion? Major factors we can see. So for first one is the nature of the metal, and next nature of the corroding environment. So what is the one by one you can see? So nature of the metal, so it depends on the properties of the metal. So what are the different properties of the metal that are giving rise to the corrosion process means, first is the position in the galvanic series. So position in the galvanic series means, we know about this electrochemical series. So those are placed based on the reduction potential. So the metal which is placed in the higher upper level, so it is having a higher oxidation potential in the galvanic series, and which is the metal which is placed in the lower, having the lower oxidation potential. So the metal which is in this higher level in this series, so it is more anodic and goes for more corrosion. So when we are combining two metals, so in the combination of electrolyte, so the metal which is having more oxidation potential, it is corroding, and metal which is having lower oxidation potential, it is not corroding. So that acts as cathode. So which is anode means the having the more oxidation potential. Next, purity of the metal. So if the metal is more pure, so there is no chance for the corrosion. So that is a major advantage. And if it is having some impurities, for example, you can take a zinc. So pure zinc cannot corrode, but when it is combined with the lead and also magnesium, so what happens are other sulfates, it forms an electrochemical cell, and immediately there is a redox reaction. So in this way, the purity of the metal is advantage in avoiding the corrosion. So if it is having the impurities, so that is a chance for more corrosion. Next, nature of the surface film. So generally when you are seeing this metal, so this metal when is exposed to all type of atmosphere conditions, a surface film oxide layer is formed. So the metals which are having more oxide layer, so those are protected, and the metals which are having less oxide layer, so they are not, they are unprotected, and they are prone to more corrosion. So that is called as oxide specific volume ratio. So when these metals are exposed to surface, when these metals are exposed to this oxide, oxygen or any type of moisture, so okay, the nature of the surface film decides the corrosive process. Okay, so more oxide layer, it is protected, and less oxide layer, it is prone to the more corrosion. Okay, next, solubility of the corrosion product. So what is meant by solubility? If I take an example, zinc or lead, so when it is taken electrolyte sulfuric acid, so lead, it is combined with this sulfuric acid, and its combination with lead sulfate. So lead sulfate, definitely it is soluble in any type of corroding medium. So finally what happens? So lead sulfate, it is soluble in the corroding environment means, so it is not allowing for further corrosion. So in that way, the solubility of the corrosion product is also deciding the corrosion process. Okay. Next, relative areas of anodic and cathodic part. So where they have combination of so many metals, combination of metals in different infrastructure. Okay, when this anodic area is small and cathodic area is large, there is a more chance for the corrosion. Okay, if I take any type of infrastructure made up of copper and rivets made up of steel, so the steel is with a small anodic area, So means more current density and more cathodic area with copper. So what happens? So it demands more electrons. So anode is completely corroded. In that way, so more, less anodic area and more cathodic area decides the corrosion process. So this is the nature of the metal based on the properties of the metal. We can say based on the galvanic series, the position in the galvanic series of the metal. Next, purity of the metal. Next, nature of the surface film, that is oxide layer. Next, solubility of the corrosion product, whether it is soluble, whether it is not soluble, that also decides. Next, relative areas of anodic and cathodic parts. Next, coming to the nature of the corroding environment. So nature of the corroding environment decided by the temperature. Next, humidity. Next, effect of pH, whether it is acidic or alkaline. Next, conductance of the corroding medium. Next, finally, oxygen concentration. So how this temperature, humidity and pH and conductance of the corroding medium, next oxygen concentration decides the corrosion process of different metals, you can see. So generally, if you see the temperature, so temperature, when there is a high temperature, it enhances the rate of corrosion. So even the passive metal, definitely in the more temperature area, it gets corroded. Okay. Next, humidity. So more moisture on the metallic surface or the corroding environment. So there is a more chance for the formation of electrochemical cell in the combination of the moisture and the anode part. So in that way, more humidity increases the more corrosion process. So that is a chance for the more corrosive of the metals. Next, effect of pH. So generally acidic pH decides the corrosion. So there is a less pH, so that metal in the less pH solution, for example, dilute HCl and concentrated HCl, if you take, so the metal in this concentrated HCl will corrode more compared to the dilute HCl. So the metal, when it is affected with in the more acidic medium, it gets more corroded. So next, the any type of metal which is affected with alkaline medium, it is less corroded. So that is the process of going on here. Next, conductance in the corroding medium. So what are the chances of these metals if you see the in the corroding medium? So if you take the water, if you take the iron pipe and kept in the water, so the part of this iron pipe in this water acts as anode and the upper part acts as cathode. So the corroding medium also decides the corrosion process of any type of metal. Next, oxygen concentration. So what is this oxygen concentration means? So when there is more oxygen level at that metallic surface or any type of alloy, so okay, that oxygen will definitely go for oxidation corrosion. Okay, so there is a process called as oxidation corrosion. So the metal definitely attacks with this oxygen, and finally there forms an electrochemical cells. Okay, an anode and cathode. So there is a more chance for the metal to get a more oxygen concentration, more corrosion process. Less oxygen concentration, less corrosion process. So this is the proportionality, we can say. So nature of the corroding environment, we have discussed about the temperature, next humidity, next effect of pH, whether it is acidic or alkaline medium, next conductance of the corroding medium, next oxygen concentration. Okay. So what are the effects of corrosion? So why should we discuss about this corrosion? Means we should have the knowledge about the effects of corrosion, because there is a loss of economic loss is there. There is a health disadvantages are there. Next, demerits in the loss of the historical monuments is there. Okay, and environmental damage is there. So, and also apart from this, there is a reduction in the strength of the material. Next, lifetime is reduced. Next, metallic properties are lost. So wastage of the metal. So if you observe any type of metal, what happens here? So you can see that is a simple process. The metallic surface is there. It is prone to different type of environment. So oxide layer will be forming on the surface. So general public will think that so it is not damaging any type of infrastructure. So we can't have more investment and avoid that corrosion. But so it is a regular process, means there is a loss of strength and lifetime is reduced, metallic properties are lost, wastage of the metal. So first one is deterioration. So the cost and appearance of this metal will be lost. There is a major process going on. Next, efficiency of the metal is reduced due to the loss of the mechanical strength, and we can see the all type of pipelines, so which are kept underground. So the pipelines so are blocked, and also the boilers get damaged, and the water pumps they get struck. So in that way, all these type of metals which are made up of with the good infrastructure, good type of metals, so they get definitely corroded if there is no kind of protection method. And next, buildings and monuments definitely get damaged. And then finally we can see so we can see the type of materials, so which have good ductility, malleability, and also good conductivity. So all these general properties, physical and conductive properties, will be lost. So that's why, so we have good controlling methods. We shall also discuss about this next, and maintenance. So why corrosion control should be continuous process, means first we can see the economic aspects. So it can be referred to as cost of corrosion under direct loss and indirect loss. So we should avoid the direct loss and indirect loss. So that is a major advantage by controlling this corrosion. Next, health aspects. You can see the regular usage of these surgical instruments and domestic appliances in both kitchen and also in the health. Okay. So why corrosion control? So economic aspects, it can be referred to as cost of corrosion, both direct loss and indirect loss. Next, we should avoid that losses. Next, health aspects. So surgical instruments, so when you are using pacemakers, different types of surgical instruments like implants, so definitely when they were using it different environments, so alkaline, acidic, and different solvents, so what happens, so definitely they are prone to the corrosion. So there is definitely we have some methods to control that. Next, cultural aspects. So antiques and monuments, so which are prone to different type of environment, definitely they will get corroded. So regular paintings and regular finishing should be there. So finally, safety aspects. So machine parts in factories, okay, and home appliances can cause harm. Okay, so if corroded, so that is a major disadvantage where going on so continuously. Okay, so next part is a corrosion control method. So just I want to see one example about how this cathodic protection is going on. And next, with so two methods we have: sacrificial anode and impressed current anodic method. So in this process, what happens? What is the cathodic protection? So coming to the protection methods, how this corrosion can be protected. So we have two best examples. We have good methods, cathodic protection methods. So cathodic protection is nothing but so where we are converting the active metal or protected metal to cathode. Okay, so we are converting completely the protected metal from anode to cathode. So in that way, so we can go for two methods. First example is so sacrificial anodic method. Next, impressed current method. So these are the regular methods where we are following so to protect the different types of infrastructure, underground pipelines, and also the different types of transformers or electrical equipments. Okay, so cathodic protection. So simple principle. So the active metal or any type of protected metal is converted to cathode, so that it is protected. And in this way, we can see the explanation under sacrificial anodic protection method and also impressed current method. So we can see the diagram. So where we can have good explanation about the process, where we can see the video also. So where the metals which are prone to different types of environment. So how can we protect the by using these two methods? Okay, so this is the general sacrificial anodic method. So diagrammatically you can see, so the metal which is to be protected, so the metal you can see the iron pipeline. Best example, iron pipeline is the one method where we can protect. So we are connecting that protected metal to the anode. So that may be the zinc or magnesium, okay, which is more oxidative. So which is having more oxidation potential. Okay, here what happens? So here when the corrosion environment is there, electrolyte is there, soil is there, here anode is there, and one protected structure is there. So we are definitely using one active metal, so which is more anodic compared to the protected structure. So what happens here? So definitely all this zinc or magnesium which is more anode definitely loses the electrons. So all these electrons will be lost and moving towards the protected structure. So in that way, this is a protected, iron pipeline is protected underground. Next, the metal which is sacrificed, okay, here maybe the zinc or magnesium, and the method is called as a sacrificial anodic method. And next method we can see the impressed current method. So this is the opposite direction. We have the source to nullify the corrosive current. From external source we are using the current, okay, and allowing towards the protected structure. So for what happens here, the corrosive environment is there, next anode is there. Here we are anode, you are using any type of graphite, and it is kept under the one black film which is made up of graphite and which is made up of the coke, so to enhance the good connectivity. Okay, here directly the current is moving from external source to the protected structure, so completely it is protected. So in that way, so we are protecting the underground pipelines and underground electrical circuits. Okay, so wherever there is a protection method, we can use either sacrificial anode and impressed current method. So what are the advantages? And you can see this video. So a good example where we are nullifying the corrosive environment and also protecting the infrastructure. So what happens here in this cathodic protection? So you can take one corrosive environment and one structure which is prone to more weather conditions, like harmful gases may be there, and moisture is there, and clay is there, okay, which is a mixture of different types of corrosive. So how can we discuss this video? Means we see the corrosive environment. Generally underground iron pipes are exposed to corrosive environment in the soil, so hence they are corroding regularly. Okay, so but when iron pipeline is connected to more anodic metal, what happens? Like magnesium, and so which is in the top of the galvanic series, so it is acting as an anode. So completely anode, it is sacrificing and it is giving complete electrons to the protected structure and is converted to cathode. So a very good cathodic protection method. So where iron pipeline is protected and magnesium is sacrificed. So that's why this method is called as a sacrificial anodic method. And next we have the impressed current cathodic protection method. Here metallic pipe is connected to the negative terminal of an external battery. So from the external battery we are allowing the current, so that it is converted to iron pipeline is converted to cathode, and graphite similarly as it is acting as a anode. So in that way, so it is also connecting the having the good connectivity to the corroding environment, okay, and also it is completely losing its electrons. So immediately we can replace this. So immediately we can replace this method. So this is a more advantageous process wherein this impressed current method, cathodic protection method. So from this external source, we are allowing the complete electrons, and also we have this anodic part graphite is protected in the backfill, and in the battery, from the battery we are allowing the electrons. So finally what happens, so complete iron structure is protected, and this method is called as impressed current cathodic protection method. So these are the two different methods we are generally following for controlling this corrosion process, and for different types of infrastructures which are in underground and which are in different types of environments. So finally, so what are the benefits of this corrosion? If you see different types of benefits, so why we are going for continuous corrosion controlling these methods? Okay, and finally we are having some advantages, means economic benefits. So economic benefits we have. So economic benefits. So economic, what are the economic benefits, and what are the environmental benefits, and what are the safety benefits? So coming to this economic benefits, so we can protect the different types of monuments, different types of infrastructure, and we can generate more revenue, so without deterioration. Next, environmental benefits, by reducing the risk of leaks, we can control the water pollution and air pollution. So this is a major advantage, and hazardous materials are also not allowed into the water. Next, safety benefits. So corrosion control can prevent malfunctions. Corrosion control can prevent the malfunctions, so that can lead to injuries and even loss of lives. So by different corrosion control methods, we have the economic benefits, next environmental benefits, and also safety benefits. So finally, by using the scientists are developing based on the corrosive environment, there are different types of methods are employed in different infrastructures and different industries. Okay, so to protect the different types of materials based on the nature of the metal and based on the nature of the corroding environment. Okay, so in that way, so this discussion was elaborately discussed, starting from the definition, and next, and what are the causes of the corrosion, different causes of the corrosion, and next, what are the different factors are prone, or factors for the increasing the rate of corrosion based on the nature of the metal and based on the nature of the corroding environment. Okay, and finally we have discussed about the what are the effects, so major effects that are going on for the loss of the ductility, and loss of the malleability, and loss of the strength, and loss of the efficiency. So to avoid all these effects, so this environment, so we are avoiding this corrosive environment. Okay, and going for the protection methods, so that cathodic protection methods we have discussed about the, so sacrificial anodic protection method, and also the impressed current method. So where we are protecting this application for this sacrificial anodic method. So generally the ship hulls, so which are moving in the ship hulls which are moving in the ocean. So continuously they are prone to the maximum moisture. So we are following this sacrificial anodic method. Next, to protect these pipelines and to protect the different types of electrical equipment, underground electrical equipment, we are using the impressed current method. Okay, so in that way we have the very good discussion about this topic, corrosion and its control methods. So this is the topic today, so about the corrosion and its control methods. Thank you.